Hi, it's Little Math, and today we're going to be talking about dot products. So, last two videos I spent talking about vectors, and you may be wondering, what else can I do with vectors? Like, obviously, they're very helpful, especially in physics, to describe not only a point, but a direction, like a distance in a direction, but there are things you can do with vectors and things that you can calculate with vectors to get more information. And today we're going to be talking about dot product. Now, there are two different ways that you can calculate dot product based on what you're given. So we'll go over both of those and some applications of dot products. So first things first, so dot product is just a way of combining vectors, and it's often also known as the scalar product because the result that you get from taking a dot product of two vectors is you get a scalar. So you get a number, you're taking a vector, which is a quantity that has a number and a direction, and you're multiplying it with another vector so that you can just get a scalar, something that doesn't have a direction, it's just a number, just a quantity. And so there are two ways that you can find this. So and also it has special notation with it. So whenever you see it written out as like vector A dot, and it's really important that you do the dot because that's how you indicate it's a dot product, hence the name. Dot B vector, and say you're given this equals the sum of AI times BI. Now what does that mean? Okay, say you're given vector A equals, say A1, A2, A3, right? You say you have an X, a Y, and a Z component. And then vector B equals B1, B2, B3, again, you have an X, a Y, and a Z component. Then basically what this is saying is that every corresponding component every component in the A vector, you will multiply by the corresponding component in the B vector, and then you're going to sum each of those up. So if we're using these vectors, like it'll be A1, B1 plus A2, B2 plus A3, B3, and so on and so forth. If you had a smaller vector, it would, like, say you didn't have the A3 or B3, then it would just be A1, B1 plus A2, B2, right? Like, you wouldn't have those. Or say you had a fourth component, well, you'd keep adding for as many, or you'd keep multiplying and adding for as many as you had. So, and you can, we can do an example with numbers, so although the math behind it is not terribly challenging, but like, so say we had 1, 2, 3, and yes, I am picking very easy numbers because my basic math skills are a bit rusty. And then we have 4, 5, 6. So then what we're going to do, if we want to take A dot B, we're just going to do 1 times 4 plus 2 times 5 plus 3 times 6, and then it'd be, this is the hard part, doing the math correctly. And then that'd be, what, 32? That seems right. So you'd get, and see, we got a scalar from that, right? It's just 32. It doesn't have a direction to it. So that's why it's called a scalar product. So this is assuming, right, that you're given basically the coordinates of you're given the values of the different components of the vector, right? But you're not always going to get that. And so this is why we can also solve it geometrically. So the other way that you can do this is, say you have, okay, again, A dot B, but this dot product, this easy multiplication stuff, is derived from the law of cosines. So another way that you can do it is taking, what is it called? The magnitude of A, right? That's what the absolute value is. Magnitude of vector A, you just want to know the scalar quantity attached to A, times the magnitude of B times the cosine of theta. In this case, where we have two vectors, and this would be that theta. So this is like vector B, vector A, and that's that theta that you're looking at. And you can derive this equation from the law of cosines. I will not be doing so, but you can. And so basically this is just if you're not given, well, it's another way to compute that. Say that you're given the magnitudes, you're not given the points, but you're given the magnitudes of A and B and the angle. And you can also, I'll show you later, but say you're given like these values, you can use that to figure out what the angle between the two vectors is. So it's helpful to know both versions. It just depends on what type of problem you're going to do. And remember, this is that when I say magnitude, if you are given this, it's just that square root of a squared plus, well, I guess in this case it'd be a1 squared plus a2 squared plus a3 squared. That's just what that is. And again, same for the magnitude of b. And let's see, some other stuff. I forgot what this is called, but say you're doing a dot b plus c. Oh, distribution. That's the word. Doing this is the same as doing a dot b plus a dot c. Those are the same thing. So I guess that's always a helpful thing to know in math. And so you may be wondering, like, okay, this is great and all, but like, what do I do with this? And so one of the things that you can use the dot product for is to find out whether two vectors are orthogonal. And now you may be wondering, well, what is orthogonal? That's just like a fancy word. So orthogonal means that the two vectors are perpendicular. Oh, and I don't know how familiar you are with different math notation, but obviously this is used sometimes to symbolize perpendicular. Yeah. So it can be used to tell that because it's based on the law of cosines, and because this is a form of the dot product. If you think about it, if two vectors are perpendicular, that means that angle between them is going to be 90 degrees, and cosine of 90 is 0. So if you take the dot product and you get 0, then the two vectors are orthogonal or perpendicular. So what you end up getting is, if you take, just to write that down, if you take the dot product of A and B and it equals 0, then that means that A is perpendicular to B. Again, because it's based on the law of cosines, because this is a form of finding the dot product. So now, on to more applications. Again, as I kind of hinted towards earlier, you can also just kind of use this to compute different like lengths and angles based on what you're given. So this is usually it's usually most helpful to, in that case, to use this formula. So like, to kind of show you, so say we have, okay, I'm going to try and draw a three-dimensional plane. It's going to be very bad because I'm very bad at that, but it's okay. Okay, so this is our X or Y and our Z. And say we have 3 points. I'm going to make them easy because I don't really want to. Okay, so this is, I was going to make that P, or not P, whatever. So this is Q, this is R, and this is S. And say we know what the coordinates for these points are, so we know Q is like 3, 0, 0. They don't have to be on the axis, it's just easier math if you do it that way, so that's why for this example I'm doing that. The Y is 0, 2, 0, and, the S coordinate, and R is 0, 0, 4. Okay, so say we can do that, and we can turn this into vectors RQ. So we're gonna have RQ, and we're gonna have RS. And say we want to know what is this angle right here between those two vectors. Well, what we can do is we can use dot product. So we know to find this angle, we can take the dot between the two vectors, which is going to look like this. And that is going to be the same as the absolute value of, or not absolute value, I'm sorry, that's the notation that's used, but the magnitude of RQ and the magnitude of RS times the cosine of that angle. So this, you're like, okay, well, how do we find this? Well, that's when we use the A1, B1, this version. So basically what you're going to end up with is, okay, to rearrange to solve for theta, you're going to get RQ, RS, oh, I forgot to put, this is all, or it's fine, I'll put the cosine there. And then to get rid of that, you'd obviously do inverse cosine. But here you're going to have, well, I don't really want to do you're going to find the difference to find RQ. You're going to find the difference between R and Q. So I think it should be 3, 0, -4. And then for RS, it's going to be, I think, 0 to -4. So you're going to find those two. And then basically you're going to, so this RQ will have an X, a Y, and a Z component. And RS will have an X, a Y, and a Z component. And you'll just multiply that from each. And so you'll get a scalar up top, right? Because dot product gives you a scalar. And then on the bottom, you're just going to do the magnitude. So again, you'll take that coordinate, which I think is 3, 0, -4. And you'll do square root of 3 squared plus 0 squared plus -4 squared. And then you'll times that by whatever quantity you get out of that. You'll multiply it by square root of, I think the coordinate is, 0, 2, -4, so it'll be 0 squared plus 2 squared plus -4 squared, and then square root of all that. And then you'll take, so basically, because both of those, the magnitudes give you a scalar, dot product gives you a scalar, you're going to end up with a number here, and then you'll just take the inverse cosine of that, and that'll give you the angle. So that's, again, kind of why it can be helpful to know that. As I said, it can help you detect orthogonality. So if you take a dot product and you get 0, then you know they're orthogonal. Trying to see. The sign of the dot product can also tell you some things. So if the dot product is greater than 0, that means that theta is going to be less than 90 degrees. And again, this is just, if you think about like cosine, because you're using cosine, so it's basically, if you take the cosine of that angle, you're going to get positive if it's less than 90 degrees. If it's equal to, as I said, that means they're orthogonal, so that means that you're going to get 0. And then if the angle is greater than 0, then theta is going to be greater than 90. Because again, if you think about it, like if you take the cosine of 170 degrees, you're going to get a negative value, versus if you take the cosine of 45, you're going to get a positive value. And obviously, the magnitudes of A and B won't have a negative or positive with them because you're squaring them and taking the square root. So the only place that sign is coming from is from the cosine, which means it's coming from what the value of the angle is. So yeah, that's kind of a rundown of, that's kind of a rundown of dot product. So yeah, there's other stuff that you can do with it, obviously. Also, if you know two vectors are orthogonal, and say you're missing what an x component is or something, you can use the fact that you know. So say you have 1, B3 for, this is vector A. I really like using vector A, that's just so nice. And then vector B is, say, 2, B0, and you know that they are perpendicular to each other, and say you want to know what is the value of B that will make them perpendicular, then you would just do, you can use that to find, I don't know if they're I don't think these two can be perpendicular, but I guess, so I picked very, very bad values. I think one of them has to be negative. We'll make this into a negative. You could also, that also shows you that there are some that you cannot make perpendicular, some vectors that, given the coordinates you've been given, you can't, there's no value that will make them perpendicular, but I'll change that too. So here we have what? -2 plus b squared. So then you know that b has to be plus or minus the square root of 2 if you want those to be perpendicular. So yeah. Okay, thanks for watching. Hope the video was helpful. I will be back to explain more Calc 3 stuff at some point. So, yeah, thanks.